Hello there, this is Group 16. Hope everyone is staying safe and healthy. We are Marcus and Theodore, and this is Theodore speaking. Now we'd like to introduce you guys about our project. During the past month, we've been thinking about what to do with our project. Two dudes dropped out of the team, and we have to reset the target to balance the workload at this very hard time because we are working from home. So in our original plan, we thought in current implementation of RustOS, we haven't fully utilized the ports embedded in our Raspberry Pi. Our actions on it are highly reliant on the computer and UI interface that we implemented in the previous labs. Therefore, we want to control the I/O by USB and HDMI ports of the Raspberry Pi. To visualize our work, we decided to use a keyboard and a plug-in screen, respectively. Interaction with keyboards by typing some words on it and output the shell to the screen are great ideas according to our original plan. However, as I just said, the dropping out of our teammates made us have to cut half of the plan. So right now, we are actually trying to implement the external keyboard input from the Raspberry Pi, which we can monitor through the shell that we implemented in previous lab. So the first thing, of course, we bought the hardware. We bought an adaptive keyboard. And before we start actually coding, we searched the internet for references that we can rely on, because this is the first time that we get our hands dirty on this type of project. The first thing we found is the documentation of Raspberry Pi. It described detailedly about our target in the USB session at the very end of the documentation. The USB core used in the video core is built from Synopsys IP. Marcus is going to introduce about the Synopsys IP later, because this is a very inconvenient thing for us to do, because it is actually require private access, and you need to buy it, and there are a lot of limits on it, so we can not actually get a lot of help from it, but later we solve the problem from another way. And besides the information provided about it, another important information we noticed was MDIO. The documentation clearly described the register we're gonna use: USB MDIO control, USB MDI generation, and USB VBus driver. However, this was still a little bit abstract for us, so we decided to keep on searching. And during our process to find other related materials, we found a thing called the Circle USB library. Circle is actually a C++ bare metal programming environment for the Raspberry Pi. And luckily, built up on that work, there are some existing projects implementing USB driver from the library, but actually using C languages. We thought this would be a good starting point, because those can be the project that we can take a good look at it and have some basic knowledge about how to understand this information and combine them together with our current operating system. So about the work distribution, for simplicity, we just support English only here. And I started by constructing the keyboard library and mapped the key to input. Marcus was responsible for connecting my job with our current operating system. So now it's Marcus' turn to introduce you something about our project.
Guys, this is Marcus. Next will be me to talk about our final project. To mention it again, the motivation of our project is to utilize more interfaces of Raspberry Pi instead of just using GPIO and etc. As Cyril just mentioned, our plan has changed from implementing both HDMI and USB device driver to only implement a USB driver, specifically a USB keyboard driver. Currently, our team has roughly finished a naive keyboard driver upon our RustOS. We've implemented a module under the Pi directory, co-located with GPIO, UART, and etc. Since the SOC's document mentions that the USB course menu is on Synopsys' website, as Theodore said, it is only accessible for certain company users, so we got stuck on it for a while. We figured it out by referring to some helper code on bare metal Raspberry Pi's USB driver written in C and C++. Through that code, we inferred both registers addresses as well as information on a USB block of Raspberry Pi, and also we learned quite a lot of USB protocol from it. In the next few weeks, we plan to firstly complete our keyboard driver, as it's not quite stable yet, and we wanted to support all the functionalities. And also, we might, if we have time, we might implement drivers for other USB human interaction devices. Yeah. Next, I will do the demonstration. So firstly, let me introduce you the hardwares. A full-size USB keyboard, a Raspberry Pi with a CP2102, and also my laptop. The procedure of my demonstration will be the following. Firstly, connect my Raspberry Pi to the laptop, and also connect my external keyboard to my Pi through the USB port. And then I will transmit the pre-built kernel from my laptop to the Raspberry Pi and start screening on it as we previously did in our labs. And then I will type some certain commands through the external keyboard. And since our project is based on the Lab3's RustOS, I will only type commands like lis and cat that is previously built in or before Lab3. So firstly, I type make transmit to transmit the pre-built kernel into the Raspberry Pi. And transmit finished, and I will type commands like list, pwd, cat, and echo. You can see the commands and the output are correctly shown on the screen. Here ends our demonstration. Hope you like it. This is Group 16. Thanks for watching.